حنبلش بأول درس. Voltage. So, أول شيء to start with, if you have a current, or if you have a circuit, voltage of Pn is going to be equal to voltage of PA plus AB plus BC plus Cn, or PB plus Bn, or PC plus Cn, any combination of something from this to this to this to this. This is like Chazel's law, like we took in math, how Pn goes to PA plus AB, this becomes PB, plus BC becomes PC, plus Cn becomes Pn. So you can use that law. If you're trying to find voltage Pn, you can add voltage of PA plus BB plus BC plus Cn. Easy rule. Second of all, PA, this voltage right here, and this voltage right here are equal to 0 because they're a connecting wire. If you have, let's say, another circuit, okay, from this point to this point, there's nothing on there, it's just a wire, U is always 0. Voltage is always going to be 0 across that. If you have a switch, right, if you have a switch, okay, and the switch is closed, it acts as a wire, so the voltage is 0. If you have an open switch, مفتوح switch, nothing is going through it, then the voltage is equal to the voltage of the generator. So if you have, let's say, this circuit, let me actually draw it on this. Let's say you have this circuit. You have a generator, a closed switch, a light bulb, and an open switch. The voltage across this is 12 volts. The voltage of this, if you want to take a guess, okay, the voltage of this is going to be 0 volts because it's a closed switch, so it acts as a connecting wire. Voltage of this, if you want to take a guess, is going to be 12 volts because it's an open switch, so the voltage is equal to this voltage. Back to my notes. This is where the law of, okay, so in parallel, UBC, this thing right here, this this lamp, the voltage across this lamp, or this, مش the lamp, the voltage across between these 2 points is going to be BD plus DE plus EC. So BD and CE are connecting wires, right? So they're both 0. So it's like saying U of BC equals U BD plus UDE plus UCE, okay? Which is equal to 0 plus UDE, because we don't know that one, plus 0. So we can say that UBC equals UDE. So in parallel, the voltage is going to be equal for both. مش equal, but the voltage is going to be يعني إنه in each, it's if you have 12 volts coming من هون, okay, if you have 12 volts coming من هون, 12 are going to go here and 12 are going to go here. Next page. Voltmeters. Voltmeters, you connect them in parallel. So if you have a circuit, okay, if you want to add a voltmeter onto this, you would add it like this, okay? The positive, a voltmeter is polarized, which means it has a positive and a negative terminal. The positive terminal is called V. The negative terminal is called COM. The positive terminal of the voltmeter is always connected to the positive terminal of the battery. Like, so it's going to be on this side of the circuit. So you would put, this is a positive. The negative is going to be facing the negative side of the battery. So it's going to be here. That's a digital voltmeter. An analog voltmeter looks like this. It's got like a little arrow that points to the divisions. So what you want to do, you pick a scale. For this one, the scale is 10 volts. So every like tick is going to be 10 volts. And then you look at the division occupied by the arrow. So the arrow, where is it? Is it on the 3rd division, 4th division, 10th division, 20th division, masalan? And then you look the number of total divisions. Okay? So there's a formula that comes from that, where to get the voltage off of an analog voltmeter, the voltage is equal to the scale times division the arrow is on, divided by the total number of divisions. We've got an oscilloscope. Oscilloscope is drawn as a graph, a Mischel graph. It looks similar to a graph. It looks like this. The positive part of an oscilloscope is called the phase. It looks like this little arrow right here. The negative part is the mass. It looks like this broom. On the oscilloscope, you can get the voltage by using the vertical sensitivity times the Y. Vertical sensitivity will often be given, it's like a scale, it's most of the time, biatukoniyeho, and the Y is how many divisions it is. So, if you have this, you've got this graph, okay, this is 0. 1, 2, 3. Vertical sensitivity, let's say it's 2. Okay? The line that you've got is on the 2nd division. So the Y, look how you can count the divisions. 1 division, 2 division. So Y on this is 2. So vertical sensitivity is 2, Y is 2, so U equals vertical sensitivity times number of divisions, which is 2 times 2, which is 4 volts. Pretty easy. Another thing that you need to know about voltage is that it can be known as potential difference or electric potential. So electric potential is at one point in the circuit. So it's not this whole thing, it's at this point right here. What is the electric potential? Let's call this point A. At point A, what is the voltage or the electric potential? It's written not as UA, it's written as VA. Electric potential always requires a reference or common ground. If they tell you that a point on the circuit is the reference or that it's the common ground, then the electric potential of that point is going to be 0. So if they give you this circuit, okay, and they tell you, let's name it PNAB. If they tell you VB, or no, point B is the reference or common ground, that means VB is going to be equal to 0, which you will be able to use in your calculations. So if you have, look here, you've got UPA, or UPA is, no, let's not use that. Okay, UBC, here we said it's 2 volts, right? So if UBC is 2 volts and C is the common ground, let me draw it out for you to make it clear. Okay. I'm just going to use a slightly more simplified one, where this is point B, this is point C. UBC equals 2 volts. Okay? They told you point C is the reference. So UBC equals VB minus VC. So because the B is first here, you put that first. Because the C is second, you put that second. Because C is the reference, that means VC is going to be equal to 0. So you can say 2 volts equals VB minus 0. So VB equals 2 volts. So electric potential at this point right here is 2 volts. One more thing. Voltage goes from low potential energy to high potential energy. So UPN is from N to P. UAB is from B to A. UBC is from C to B. The current, it's basically opposite to the current. Current goes from positive to negative, voltage from negative to positive. Pretty easy. That's the first lesson of physics.